In November 2017, a team of physicists aimed a detector at the Great Pyramid and looked through 4,500 years of stone using particles called muons. They found a room, not a previously known room, not a chamber mentioned in any historical record or discovered in any prior excavation. A previously unknown void, at least 30 metres long, sitting directly above the Grand Gallery. Nobody put it in the textbooks. Nobody explained what it is. Nobody knows what it contains. The most studied structure in human history still has a secret room. That is where we are starting today. Hard Truth Science, Episode 6, Built Once, Never Explained. What people know, and what the textbooks leave out. The standard account of the Great Pyramid is this. It was built as a tomb for the pharaoh Khufu around 2560 BCE by a workforce of tens of thousands of labourers over approximately 20 years. The techniques used included earthen ramps, wooden sledges, and the organisational capacity of one of the most powerful states in the ancient world. This account is broadly accepted by mainstream Egyptology, and it is not wrong. The evidence for Khufu's association with the pyramid is real. The workforce villages have been found and excavated. The logistics, while extraordinary, are not physically impossible. But this account has gaps that are rarely acknowledged. Serious gaps. Gaps that professional engineers and physicists, not conspiracy theorists, have been pointing at for decades. The first gap is in how the precision was achieved, not just the overall scale, the tolerances. The casing stones that once covered the pyramid's surface, most of them are gone, stripped over centuries for building material, were fitted together with joints of approximately 0.5 millimetre, across stones weighing up to 80 tonnes. Modern stonemasons, using modern tools, have significant difficulty replicating this. With the tools available in 2500 BCE, copper chisels, stone hammers, wooden measuring rods, the question of how this was achieved does not have a satisfying answer in the current literature. That is the first gap. The second is more surprising. The second gap is this. No mummy has ever been found inside the Great Pyramid. The sarcophagus in the king's chamber was empty when Arab Caliph al-Mamun breached the pyramid in 820 CE. No burial goods, no inscriptions, no evidence of interment. This is unusual. Every other confirmed royal tomb in Egypt, the ones in the Valley of the Kings, the smaller pyramids, the mastabas, contains or contained clear evidence of burial. They are covered in hieroglyphics describing the deceased. They include canopic jars, furniture, food offerings, ushabti figures. The Great Pyramid has none of this. No hieroglyphics on the interior walls. No decoration of any kind in the main chambers. Nothing. The standard explanation is that the pyramid was robbed in antiquity, before any historical record of it being intact. This is possible, but the complete absence of any inscription, even painted cartouches, which robbers would have had no reason to remove, is hard to explain. There is a single quarry mark found in a relief chamber in 1837 by Howard Weiss that contains the name of Khufu. It is the only text in the entire structure, and it is in a location that was sealed and inaccessible from the time of construction. The pyramid was not built the way Egyptian tombs were built. If it was a tomb, it is unlike every other tomb in Egypt. The hard truth, the precision problem, and the granite question. The Great Pyramid is aligned to true north with an accuracy of 3/60ths of a degree. That is 0.05 degrees of error. For comparison, the Paris Observatory, built in 1671, is misaligned to true north by 6 minutes of arc, 6/60ths of a degree. Twice the error of the Great Pyramid, built 4,000 years later with the benefit of telescopes and precision instruments. The base of the pyramid, 230 metres on each side, varies in length by less than 20 centimetres across all 4 sides. The base is level to within 2.5 centimetres across the entire footprint. These are not approximate achievements. They are not close enough achievements. They are extraordinary feats of precision that engineering historians acknowledge without being able to fully explain the methods used. The construction timeline makes this harder, not easier, to understand. 2.3 million blocks, averaging 2.5 tons each. 20 years of construction. That is approximately 800 blocks placed per day. One block every 2 minutes, around the clock, every day for 20 years. That calculation has been in the literature for decades. No fully satisfying explanation of how the logistics worked has emerged. The granite problem is the part of this story that receives the least attention and deserves the most. The king's chamber, the main upper chamber of the pyramid, is lined entirely in granite. The walls, floor and ceiling. The sarcophagus, the 5 relieving chambers above it. This granite came from Aswan. Aswan is 800 kilometers from Giza. The individual granite blocks in the king's chamber weigh between 25 and 80 tons. The largest granite blocks in the entire structure weigh up to 80 tons. Granite has a Mohs hardness of between 6 and 7. Copper, the hardest metal available in ancient Egypt, has a Mohs hardness of 2.5 to 3. You cannot cut granite with copper tools. The copper is softer than the stone. The granite in the king's chamber is worked to precise tolerances. The surfaces are flat. The joints are tight. Some surfaces show evidence of having been polished. The conventional explanation involves harder stone tools, diorite hammers and dolerite pounders, which are indeed harder than granite and have been found at Egyptian sites. These tools can abrade granite. They are less good at cutting it to precise tolerances at the scale and volume seen in the pyramid. The full explanation of how the granite work was done remains an open question in the archaeological literature. The examination. What the 2017 discovery changed. In 2015, an international team of physicists launched the Scan Pyramids project, a non-invasive survey of the Giza pyramids using multiple imaging technologies, including muon tomography. Muons are subatomic particles produced when cosmic rays hit Earth's atmosphere. They pass through solid matter, but they are absorbed differently depending on the density of what they pass through. By placing detectors inside and around the pyramid and measuring the pattern of muons that arrive, researchers can effectively X-ray the structure. In November 2017, the team published their findings in Nature. They had identified a previously unknown void at least 30 meters long above the Grand Gallery, the tall, corbelled passage that leads to the king's chamber. This finding was confirmed by 3 independent detection methods. It is not a measurement artifact. There is a large empty space inside the Great Pyramid that no one knew about before 2017. The team was careful in their language. They called it a void. They did not speculate about its purpose. They noted that it could be a construction void, an internal space left to redistribute stress during building, or it could be a chamber with an as-yet unknown function. As of today, it has not been accessed. No drill, no camera, no investigation of its contents. The Egyptian government has not approved any intrusive investigation. The Scan Pyramids project also produced thermal imaging results that raised their own questions. Thermal cameras scan the pyramid's surface at different times of day as it heats and cools. Most of the surface behaves as expected. The stone heats and cools uniformly. But several anomalies appeared. On the east face of the Great Pyramid, 3 stones at ground level showed consistently higher temperatures than the surrounding stones. The team described this as a particularly interesting anomaly and noted it could indicate an internal void, air movement, or a different material. It has not been explained. The Scan Pyramids team continues its work. They have proposed further investigation using additional technologies. The full picture of what is inside the Great Pyramid is not yet known. And this is the point at which mainstream Egyptology becomes an active debate rather than settled history. The purpose of the structure, the reason for the internal layout, The reason for the shafts that point to specific stars, the reason for the complete absence of decoration, is genuinely contested among researchers who all have access to the same evidence. The honest conclusion: what we know, what we have never known. Let us be precise. We know the Great Pyramid was associated with Khufu. The evidence for this is real, if sparser than we would like. We know approximately when it was built, within a century or so of 2500 BCE. Radiocarbon dates from organic material embedded in the pyramid's mortar support this. We know the workforce existed, their village, their tools, their administrative records have been found. These were not slaves. They were skilled workers who received food, medical care, and burial. What we do not know is precisely how. The ramp hypothesis, the internal spiral ramp hypothesis, the water lubrication hypothesis, the kite and pulley hypothesis. None of them fully accounts for the precision achieved, the rate of construction required, and the granite work in the king's chamber. And what we do not know, what is genuinely, documentably, historically uncertain, is why. The tomb theory is the consensus. But consensus built on absence of contradiction is not the same as evidence. The pyramid does not look like a tomb. It contains no burial. It contains no text. Its internal geometry, the shafts, the chambers, the proportions, has generated serious academic debate about astronomical, geodetic, and religious functions that the tomb theory does not address. And there is a void above the Grand Gallery that no one has entered. We do not know what is inside it. The most studied structure in human history still has unanswered questions that serious researchers take seriously. The examination is still open. Hard Truth Science. The examination is still open. Follow us on YouTube at Hard Truth Science.